that. Okay, recall that. Remember, we create two so-called power reducing formula for the double angle, if you like. So that would enable us to get this thing. So recall that by the power, remember power reducing formulas. This is what we had for with this one. So we would like to reduce the power. We start with if you have something like a sine squared. Okay, so if you have a sine square of alpha, okay, of alpha, we double it up, is going to be 1 minus cosine of the double angle. So you double this one, that give you 2 alpha. Okay, 2 alpha divided by 2. So whatever we have over here, we double it. Or in the other way around, if this is 2 alpha, then this is going to be 1 alpha. Similarly, we have a cosine squared. If you want to reduce the power of a cosine squared, so what we have 1 plus, okay, 1 plus cosine of 2 alpha over 2. Okay, so this is a double angle formula, or we call it power reducing formulas. Power reducing, you did have one of them in your quiz. Probably you have some difficulty to take care of that one. I know that, but we are going to check it again. So you reduce the power of the sine. This is the squares, but we double the angle. So this is cosine squared. If you want to reduce it, you check the double angle formula. Sometimes in practice, especially in some problem in physics, you need the so-called half angle. Okay, you need a half angle formula. So what's going to be the half angle? You see, if you replace this alpha by alpha half, if you replace the alpha by alpha half, okay, so what we're going to do is we are going to replace, okay, replace the alpha by alpha half. Let's see what you're going to have. Okay, this is going to be the case. Then this formula would be changed into this format. Okay, the format is going to be, this is going to be sine squared. Okay, it's going to be sine squared up, and instead of alpha, we're going to use alpha half. Okay, so that gives a sine square of alpha half, if you like. So this is going to be equal to what? So it's going to be equal to 1 minus cosine of the double angle. So when it was alpha, we call it 2 alpha. So this is going to be alpha half. The double of alpha half would be alpha. Okay, divided by 2. So the sine square of alpha half would be equal to the 1 minus cosine of the alpha half 2. So if you would like to find the sine of the half angle, you write this one first, then take the square root. The difficulty is going to be when we take the square root, you should have, a positive, negative. You should take care of it. So my suggestion is just write the formula in this format, then take the square root yourself, okay? So the sine square of alpha half equal to the 1 minus cosine of alpha half over 2. And if you check the second one, you start with the cosine, okay, cosine square of alpha half, okay, you double it. You double it when it's a cosine, the top is going to be what? It's going to be 1 plus. Okay, so the top of the 1 plus cosine of the double angle. The double angle, this is alpha half. If you double it, you get the alpha. Alpha over 2. Okay, so the best thing to memorize if this format would be better. When we want to find it, we take the square root, because that square root is a little bit tricky. So I want to explain it when we operate it. Okay, so again, in your book, it's the same of this one. Take the square root, but this is the version. This version is going to be much more useful. Okay, so these are going to be called half angle formulas. Half angles. Okay, so it's going to be half angle. formulas. It's nothing new. You can replace the alpha by anything you like. Then you double it up. But this is popular for the half angle formula. Any question? Your job for the next test, we are going to give you the alpha, and we ask you to find the sine of alpha half, cosine of alpha half. Okay, so this is going to be your job. So we get the example. It would be useful when in future you want to use it. For the time being, it's just a formula and you apply it only once and you're done. Okay, so this is the type of problems that it's a little bit, the algebra involved is a little bit tricky. We see it in minutes. Okay, so what's going to be the type of question that you have to take care of for us? We give you, you see, if a cosine of alpha is given, the cosine of alpha is going to be equal to the negative 3/5. Okay, and they are going to tell you where the alpha is. Alpha in this case is in the third quadrant. So the alpha is between pi and the 3 pi half. Okay, pi and 3 pi half. So what we want to find the exact value of the following. Find the exact value. Okay, the exact value of what? Of each of the following. Okay, so we're going to have two cases. The case one is part one. We want to find what is going to be the sine of the alpha half. Okay, what is the sine of alpha half? And the case two, we want to know what is going to be cosine of the alpha half. That's it. You need to find these two. If you want to find the tangent, you know, you have to find these two divided. But the popular one is these two, and then we be done. Okay. So there you are. Easy formula. You use the double angle formula or half angle. Start with the sine square of alpha half. Is going to be 1 minus cosine of alpha half over 2. Substitute. Simplify. Take the square root. And take the square root, then you have to check to see where you are to get that. You see that the square root is going to be positive or it's going to be negative. And for the cosine, you use the second one. Okay, so let's do it. We are going to check the part one solution. Okay, so what's going to be the solution? Solution, we go with the part one. In part one, we would like to find the sine. So we start with the sine squared because our formula starts with the sine squared. So it's going to be sine squared of alpha half. Okay, double angle formula is going to be equal to, since it's a sine, is a 1 minus cosine of the double angle. This is alpha half. You double it, you get alpha. Alpha divided by 2. Substitute. So it's going to be equal to the 1 minus cosine of alpha. What's cosine of alpha? Negative 3/5. It's going to be negative 3/5. Divided by 2. Continue on the top. Simplify. Negative would be positive. So that gives me 1 plus, okay, 1 plus 3/5. It's going to be 1 plus 3/5. So simplify it. 1 plus 3/5. This is like 5 over 5. So it's going to be 5 and 3 would be 8. So we get, okay. So this is it. You get 8/5 on the top. Okay, divide by 2 or 2 over 1 down the bottom. It's division of two fractions. You write the first one by the times the reciprocal of the bottom one. So it's going to be, we continue, it's going to be equal to what? Equal to the 8/5. Okay, 8/5 is the top one, times it by 1/2. Okay, 1/2. Now we can simplify. It's a multiplication. We simplify first. By 2, that would be 1. By 2, that would be 4. So we multiply the tops together. 4 times 1 would be 4. Okay, so that gives you 4/5. So what we have that the sine squared of alpha half is equal to the 4/5 so far. Any question? Now the tricky part is the next step. You have to take the square root, okay, to find the sine of alpha half. When you take the square root, on the other side, you are going to have a positive negative. So you have to tell us which one is going to be, are you going to use? Are you going to use the positive root or the negative root? Okay, so we continue. I have to go to the next page. Any question? So easy formula, write the formula, bring it to the test, we don't mind, but make use, when you want to use it correctly. Some people miss this negative sign. It's a sign, so it's a negative, negative, positive, simplify, take the square root now, okay? So I just repeat it here again. So what I have the sine squared, okay? So I have the sine square of alpha half, okay? Sine square of alpha half, and this is going to be equal to what? It was equal to the 4/5. Now take the square root. When you take the square root, you see it's going to be a square root of sine square of alpha half, okay? And this is going to be, you have to use positive negative. So it's going to be 4/5. You see the sine of the alpha half, the sine of alpha half is going to be equal to the positive negative. You go on the top, radical 4. You go down the bottom, radical 5. Radical 4 would be 2. So that gives a positive negative 2. This is going to be radical 5. You know that you have to multiply it by radical 5/5, radical 5/5 to rationalize the denominator. So the result is going to be positive negative 2 radical 5 on the top and the 5 down the bottom. Okay, so the sine of alpha half is going to be equal to positive negative 2 radical 5/5. Any question? Now the question is, which one are you going to use? Are you going to use the positive or are you going to use the negative? Okay, so you have to go back and check to see where are you. Okay, that is going to be the case that it is. Yes, we check it. Okay, so we are going to check to see where the alpha is. Remember the alpha?
We get it in the third.
Yeah, the alpha. Let's check the alpha. You see where the alpha was? Alpha is in the, okay, alpha is in the third.
Yeah.
You see that? You say, oh, bad. This is where some people, they miss it. You say, oh, alpha is where alpha is in the third.
Yes.
Okay, but you want to use alpha half. So you divide everything by 2.
Oh,
Okay,
yes.
so if you divide everything by 2, so that give you pi half, that give you alpha half, and this would be what? Would be 3/4.
Mm-hmm.
You see? So we divide everything by 2. That's a 90 degree. That's 180. We divided that, give me 90 degrees. Alpha half, 3/4. So now you check, where is the alpha half? Which quadrant is the alpha half? Any suggestion?
Alpha half. Let me.
Is greater than 90 degrees. You see, greater than 90 degrees, but less than, this is 135.
It is in the second
Yeah,
second teacher.
that's it. This is it. You see, you got it over here, and you know that this is cosine, and this is the sine.
Yes.
So the sine of alpha half, you see, sine of alpha half is positive. Since it's positive, you are going to pick the sine of alpha half to be equal to 2 radical 5/5. You see, that's a point about using this formula. That's why I didn't write it down in radical form to memorize it. You have to do this one all the time. You get the sine square, take the square root. When you take the square root quickly, that gives you sine of alpha half, but positive negative of the other side. Okay, you take it, radical on the top and the bottom, you simplify it. Now you have to decide. You go back to see what is your alpha or where is your alpha. Write as a algebra, not the graph. Alpha is between 180 and 270. So divide everything by 2 all the time to get the alpha half. So divide by alpha half, so that would be pi half, which is 90 degrees, less than 3 pi 4, which is 135. So alpha half is in second. Since in the second, you know that the sine is positive, but the cosine is going to be negative. You can do this one at the beginning too. When it's given to you, you see, you can just to start, you can identify the location. Okay, or you can do it through the end of the problem. Okay, any question? So that's the sine. You have to repeat it for the cosine. Cosine is going to be easy because you already got all the information that you need. So we start with the cosine square again. Cosine square of alpha half. The only difference is going to be 1 plus. Okay, it's going to be 1 plus cosine of the alpha divided by 2. So it's going to be equal to 1 plus the cosine of alpha. Remember the cosine of alpha was negative 3/5. Negative 3/5. Okay, divided by 2. So it's going to be 1 minus 3/5. Divided by 2 is going to be 5 minus 3. That gives you 2. So it's going to be on the top, we get the 2/5. Okay, 2/5 is going to be 2 over 1. So it's going to be 2/5 times the 1/2. You simplify, that give you 1/5 this time. Okay, so that give you 1/5. So the cosine squared, you see the cosine square of alpha half is equal to the 1/2. Take the square root. Okay, so if you take the square root, cosine of alpha half would be equal to, but you have to positive negative here, positive negative 1/2. So we go on the top and the bottom. That gives us a radical 1, radical half. Radical 1 is just 1. Okay, that gives you 1 over radical 2. Okay, and then you have to, okay. Oh, I missed something. I'm sorry. It's not radical 2. I was surprised. Okay, that's 5. Because I was surprised that I got the radical 2. It's a 1/5. Okay, so this is going to be a 5th. Okay, and this is going to be a 5th. So we get 1 over, okay, we multiply it. So that is going to be the case. It's a 5th. We have to multiply the top and the bottom by the radical 5. Okay, it's a radical 5 over radical 5. So the final answer is going to be, so the cosine of alpha half is going to be equal to the positive negative. The top would be radical 5, but the bottom one would be 5. But already you have it. You see, you know that this is in the second quadrant. In the second quadrant, the cosine is negative. Okay, so you already got this one that you are here. So you can name that, oh, but cosine of alpha half, okay, it's negative. Since it's negative, so the final answer would be cosine of alpha half is equal to the negative radical 5 over 5. And then you're done. Okay, so this is how we are going to, okay, yes, thank you. So this is how we are going to deal with this type of problems for the half angle. Okay, any question? So the formula is easy, but when you apply it, you must make sure that don't miss that last part. You see this because we don't know, because the information would be given to regarding the alpha. So you know the position of the alpha, but you are going to use the alpha half. Okay, so you have to get this idea, identify the, where the alpha half is. So we know that it's going to be the second quadrant. So the sign was positive, so we pick the sign, and over here the cosine is negative. So when you take the square root, put the positive negative first, and then okay, and then you change it. Okay, so it is not going to be anything new, if you like, but the idea of the half angle is going to be not for this course really. As I told you, if take calculus 2, calculus 1, and we get calculus 2, we have some formulas related to the alpha half. So then it's going to be very, very popular. The other things about the popularity is like the example that I gave you the other night, that sometimes in algebra or in calculus, something with a square root would be given to you, don't like the radicals, then use this type of ideas. But generally, this is all you are going to do for it. So we are not going to spend any more time on this one, but we give you one question exactly like this one. On your tonight, remember you will have to find the sine of 2 alpha plus the cosine of 2 alpha. And when we get to the test, we give one more problem, and then you have to find these alpha half for us, okay? And then we are done. And from time to time, we are going to, of course, use it. Okay, any question? So that is the half angle formula. So it's the same as the double angle. We just replace it to get that half angle formula. So you can bring all the formulas to take care of it. There is one more section that is good for factoring. We don't need it, so we are not going to cover that one because there are 5 more formulas. So we will be fine without those formulas. So we go on, and if we get time, we come back and we give you those formulas. But we don't need it, and it's not going to be okay cause any trouble for us because it's going to be too many formulas, and we don't use it if you want to use calculus. Okay, so we are done with chapter 5. Because I want to start that chapter 6, very important part of your course. Okay, and it takes a while for us to be able to finish it. Okay, if you want to take any course in future, you need chapter 6. Okay, so let's see what is chapter 6. We have to review a little bit of algebra, make sure that you are familiar with some notion of the functions. Okay, what is in chapter 6? There are quite a lot of topics to talk about it, but the first thing to do, we want to know what is going to be the inverse of a trigonometry function.
Oh, very good.
Okay, that's one. It's very important topics. Okay, so what is going to be the inverse trigonometric function? Inverse trig functions. Trigonometric. Okay, trigonometric metric functions. Okay, we take it slowly. If you have any question, let me go on. Let me know because that's a very, very important topics. Okay, inverse trigonometric function. First, we have to remind you what is the inverse of a function is. Okay, from your algebra, depends what type of algebra did you have before, but we suppose that we don't know anything. Okay, so we just review first because we have to review algebra first, then we get it into the trigonometric one. Okay, so review the inverse function. You see, in algebra, function is a machine. Okay, the function is going to be a machine. That machine takes something, we call it input x.
And
You drop
output.
the x, okay, you drop the x into the your
Output.
machine. So this is like a cashier.
Yeah.
Okay, you buy something, they scan it. Okay, that's going to be the cashier function. You go to the gas station, that's the same thing. You pay, okay, then give you the gas. So there's going to be an output. Action of the f on x, we call it f of x. Okay, and this is going to be our output. This is going to be definition of a function. Okay, so there is only one condition in this definition. The condition is that for each X, you must get only one Y out. Okay, so if you pay $5, they may give you one, one soda or something. Okay, one pack of cheese or whatever. Okay, they are not going to give two. So we say that these inputs, the first part, okay, which is the input. Okay, this is going to be the
output,
input. Okay, and this is going to be the output. Output. So you cannot shave the first component. For each X, you must get only one Y out. Okay, so for example, if you be given Y equal to, let's say 3X plus 5, this is a function. Okay, it's going to be a function because if you give me one X, you see if you put X equal to 2, for example, put X equal to 2, so Y would be what? Would be 3 times 2 plus 5, which is going to be 11. So I can connect the 2 and the 11 together. You see that's going to be the 1. So for 1, 2, I get only one, one numbers over here. Okay, so if if I give you this one, okay, if you have something like X equal to the Y squared, okay, if this is going to be the 1, so if you give me one number, if you give me X equal to the 1, so how many Y can I have? You see, Y would be Y squared. So what's going to be the solution? What is Y?
Plus or minus rad 1.
That's it. Yeah, it's going to be positive, negative, rad 1, which is 1. Okay, so it's going to be positive, negative 1. So in this case, you see, you give me 1. I can have 1 and 1. Okay, or I can have what? 1 and negative 1. So you see, this is, they share the first component, if you like. They're sharing the input. If you share the input, this X equal to the Y squared, okay, is not a function. Okay, is not going to be a function. So you can have a function only for each X, you can get only one Y to connect them together. Okay, that's the definition of a function. It's like, your Facebook. In your Facebook, this is you, but you have lots of friends. So your Facebook is not going to be a function because the X values are going to be, you get lots of X values. But if you switch it, if you start with you, this is your friends and you. Your friends and you would be a function because, you can go to a store and buy everything for $1, for example. So you can share the second component, but you cannot share share the first one, the X values. This is the only, condition that we impose on the function. Okay, just briefly give you this type of ideas as much as we need. Any question? Now
No.
let's see. Question. Now let's see what does it mean if we just want to use the geometry to explain this condition that we talk about it. You see the condition that we got over here, each X connected to one Y only. Each X connected to one Y only. This means if the graph this function,
Every input, there is one output.
you see, for example, not suppose this is going to be the graph of this function. You see, if I give you 1x, this means that this is x. Okay, if I give you x equal to 1, you know that the graph of x equal to 1 is a vertical line. So if you give me 1x, as soon as you give me the x, I can have a vertical line. You see, I can have a vertical line. This vertical line would intersect the graph at one point only. And that's the y that we talk about it. So when we say it's a function because for each x you get only one y. Geometrically, this means every vertical line intersect, you see, every x that you give me, every x you give me, those x's, if I get, the vertical line, this vertical line would intersect the graph of the function at 1 point only. Because if it's going to be 2 points, look at this one. This one is, if you graph it, the graph would be of this format, you see? The graph would be of this format. So if you give me 1x, as you did, if you give me 1x, then if I draw the vertical line, you see, I will be intersecting the graph at 2 points. You see, this point, that's a negative one that we talk about it. It's a positive one, and that's going to be a negative one. Okay, so as soon as we see this graph, we say, oh, this is now the graph of a function.
Yes.
Because for each x, I'm going to have two. Okay, I'm going to have two numbers for the y. Okay, so we just you know that this is going to be called the vertical line test. So just a reminder what is going to be the vertical, because that's very crucial for us to understand the topics in trigonometric function. We need this one. What is the vertical line test? Line test. Okay, so the vertical line test would be, this is going to be the one. We can say that the equation, okay, the equation y equal to the f of x represent a function, represent y as a function, okay, as a function of x, okay, if what? Each, okay, if each vertical line, okay, if each vertical line intersect the graph, intersect the graph at, at not more than 1 point. One point, or we say at most 1 point, which is the same thing. Means it's not going to be, they may not intersect each other, but if they intersect each other, there must be only one point. So that's a definition of a function using algebra, using geometry, okay, to get these numbers done. Any question? Now, what's going to be the inverse function? You see, the inverse function is going to be a kind of, you see, we say that the y is a function of x. Y is a function of x, and this is going to be the direction that we have. So the inverse is if you switch x and the y. If you switch x and the y, this is it. Okay? This is the switching one. If you switch x and the y, so you start from the y, you go to the x, this would be the inverse of the given one. Okay? That would be the inverse of the given one. But the same condition that we have. So if you want to know if this function, because you can switch it, but there is no guarantee that if you switch the x and the y, the result is going to be a function. So how are we going to find out whether the result is going to be a function? Look at the graph that we have over here. Look at this graph. You see, the test was vertical line test. But if you switch it, you see, look at this one. If you switch, that test is going to be horizontal test. You see, look at this one. This line that I talked about it is going to be a horizontal line.
Yes.
And these are going to be horizontal line. So as you can see over here, the horizontal line will intersect this graph at 2 points. So this means if you want to get the inverse of the function, you will get an equation, but the inverse is not a function because horizontal line test. You see, because everything would be switched, would be flipped if you like. But this one, you see, Nothing to worry about. Nothing to worry about. So that gives us a very nice, that's very good for trigonometric function. Okay, in algebra, you have some other device to do it. But for the trigonometric function, this is the one. Okay, so what we need to know is we need to know where the function is going to be invertible, where you can find the inverse of a function. You can find it if the graph of that function would so-called satisfy the horizontal line test. There is an expression, we call it one-to-one function, if you are familiar with, but I don't want to get involved. I just want to quickly give you an idea that's going to be very useful for trigonometric function. Okay, no algebra would be changed that one. So let's remind you what's the inverse is. Any question on this one? It's good to know it, you see, because this is a very important topics. So I don't want to just go ahead and write the formula. I want to make sure you understand it, because if you want to calculus, that would be one of your points that would be very crucial to get through it, because the inverse trigonometric function are the best tools in application in science. Okay, so that was the definition of a function. Now what's going to be the inverse of a function? Okay, that's going to be what? Okay, can you give us an example of a function in everyday life? Example of a function in everyday life?
Example of the function.
Yes, in everyday life. See, I'll give you one. Cashiers. You go to Starbucks, it's a function.
Yes.
Because you pick the X, the cashier would scan and charge you. All the fast food restaurants are functions. You go, you order a Big Mac. You know that they have they click, they click it and then give you those numbers. Okay, so all the cashiers are going to be a trigonometric function. Okay, yes, the salary paying, or yes, your salary, the way the paychecks, if you like, because the machine is they calculate your salary given to you. The other ones is your utility bills. Your utility bills, they nicely explain it for you. They say, oh, if you have something between 1 and 300 kilowatts, the formula is what's that? 52 cents, $2. But if you go over it, they charge you differently. Okay, that's going to be the one. And taxes, you don't like it, but the taxes are a function. Because if your income is between $0 and $30,000, for example, 10%, 20%, 30%, so that's a function. It's all over the places. Without function, you cannot live. You cannot justify anything in everyday life. You go to post office, it's a function. You put it on the scale, okay, they tell you if the X, the weight is between 0 and 5 ounces, 43 cents, etc. So that would be the function. You go to gas station, it's a function, it's a nice function, because you pick the type of the gas you want. As it go on, they charge, they give you the money. Remember, 2 gallons, 3 gallons, 4 gallons. So it's all over the places. That's why there are such an important quantity that we are going to have. Okay, so let's get what is the inverse of a function. Then we are going to take it into the trigonometric function. Okay, because we need this understanding first. Okay, so we define the function. Now what's going to be the inverse of a function? So what's going to be the inverse? Not trig function, just the inverse of an ordinary function of a function. Okay, inverse of the function is the one that we're going to switch. Okay, so if okay, y equal to the f of x is going to be a given function, such that there is going to be another function such that there is another function, there is a function x equal to the g of y, we switch. Okay, so if there is going to be another function x equal to g of y such that, what is that now? y is equal to the f of x if and only if x is equal to the g of y. So this means if you give me this equation, I can solve it for x. If I solve it for x, I get the g over here. Okay, if this has happened, then g is going to be called, okay, the inverse of, okay, the inverse function of the function f. The function f. Okay, it's denoted by, it is notation denoted by g is equal to the f inverse. It's just a name, it's not a power. Okay, f inverse is just a name, it's not a power. Okay, so this is the definition of the inverse function. Y is equal to the f of x if and only if you switch x is equal to the f inverse of y. So basically, this means if you give me this equation, if I can solve it for x and the result is going to be a function, then f inverse is going to be the inverse of the f. Okay, so f inverse is called the inverse function. The inverse function. Okay. Give one easy example because we are not going to be staying in algebra. We go to the trig function and we have only one inverse function. It's nice to know it. You see, suppose your function is going to be, you see, y is equal to the something easy, 2x minus 1. Okay, this is a given function here. Given function. Then if you want to find the inverse, solve for x, you see. This is going to be y equal to the 2x minus 1. Solve for x. If you want to solve for x, what are you going to do? It's going to be 2x equal to y plus 1. And you divide. So that gives you x equal to y plus 1 over 2. You see what you have? Y equal to the 2x minus 1 was given to you. Now you solve it for x. X is equal to y plus 1 over 2. So this is your inverse function. Okay, so f inverse. You see your function was f of x, so this would be f inverse of y is equal to y plus 1 over 2. You see that's what? If you don't like y, you can call it x, it doesn't matter. You can call it t, it doesn't matter. Okay, or your f inverse of x is simply x plus 1 divided by 2. Okay, so this is the meaning of the inverse function. So you have the y equal to the y is a function of x. We switch it. We switch it to be able to get it. But as I talk about it, this switching is always possible. But the question is whether you will get a function or not. That would depend on that vertical line test that we talk about it. So the condition that you can have any question, these are just to refresh your memory, but we need this condition. The condition is going to be, say, note that. As I talk about it, the vertical line test would be changing to the horizontal line test, okay? So the horizontal line test is going to be, say, a function. A function. Y equal to the f of x has an inverse, okay, if and only every every horizontal line,
has
okay, intersects the graph, okay, the graph of y equal to the f of x at not more than 1 point. That is very crucial for the trigonometric function. Okay, they call it one-to-one property, but you better get it with the geometry. Okay, so you have to check if to see if this condition satisfy. Otherwise, you see, for the algebra, you solve for x and you get it. But in the case of the trigonometric function, you have y equal to sine x. There is nothing to be solved. You see, that's why this would be very crucial for us, okay? So, for example, look at this one. Look at this. If you have this graph, okay, this graph, each horizontal line intersect the graph at 1 point only. So in this case, we say that the function, okay, so the function, if you like, whatever it is, has an inverse, okay? But you know this function. You see, look at this function. If we get a horizontal line, would intersect the graph at 2 points. So this function, the function is not invertible. You know, it's not fine. There's not any inverse. Okay, invertible. So means has no, doesn't have any. Okay, invertible means it doesn't have an inverse. All the trigonometric functions are periodic, remember? Periodic means they repeat themselves. So none of those trigonometric functions in general are invertible. Unless you do something. Unless you restrict your domain of the function so that you are going to have, a nice one. That is going to be the idea that we are going to, to follow. Okay, any questions so far? So we are just at the place that we can start talking about the inverse of the trigonometric function. Look at this graph. So we are going to take them one by one. Sine, cosine, tangent. These three would be enough because the rest are going to be the same. So for each one of them, we look at their graph to see if they are invertible. They must satisfy the horizontal line test. This means if you take a horizontal line, it must intersect the graph at not more than 1 point. So this is not invertible. So you don't have any inverse. So what are we going to do? We're not going to leave it. So what we do is we are going to break it. We are going to consider a portion of this graph that would give us that invertibility. And that portion is important. You must know it, which portion of the graph is going to be. Okay, so I'm going to talk about the sine. Are you ready? So that's just a preview, just to understand it, what is going on. Okay, so we are going to take them one by one. Okay, the best sort of example of the inverse function in mathematics are going to be, okay, trigonometric function. So let's check. We check the first one. We focus on the sine first. If you understand this one carefully, then the rest are going to be, easily followed if you like. So this is, what is the inverse sine function? The inverse sine function. Okay, so first thing to do, you have to check the graph of the sine function. So we recall that. Okay, recall that. Okay, recall that the graph. Okay, let's say the function, we know it, recall that the graph of y equal to sine x is given by, you know it. Remember how we graph it? So this is it. I'm going to consider it in one period. So we know the period is going to be 0 and 2 pi. This is it, 0, 2 pi. Remember, divide into 4 parts. So this is going to be over pi half, 3 pi half. Okay, 4 parts that we have. So this is going to be over pi half. This is pi, and this is 3 pi half. Okay. You know that the sign goes up at most 1, down 1. So this is going to be 1, and this is going to be -1. Since it's a sine, it starts from the origin. Remember, it starts from the origin, goes to the maximum. Then we get to the intercepts. Then we get to the minimum, and we arrive at the intercepts. Okay. So the top points are going to be here. Okay, so we go up, then this is going to be intercepts. Then we're going down here, and then we go to the intercepts. Okay, so this is going to be the graph of the sine function. Up to the maximum, intercepts to the minimum, then the intercepts, and it's go on. Okay, that's going one portion. Any question? Let's have a period here to the left. So we graph it in 2 periods, for example. It's going to be 2 pi. So divide by 2. So this is going to be, sorry, that's a -2 pi. So this is going to be negative pi. Then we need 1 point here and 1 point here. So what does these points represent? This would be -3 pi half. Okay, and this is going to be negative pi half. So we repeat the graph. You know that this must go down first, going to the, okay, going to this point, which is going to be the minimum, intercepts. So we get a maximum and the intercepts. So if we continue the graph, this is going to be the graph. Okay, that's going to be the sine graph. Y equal to sine x. Any question? Quickly, you know that it fails the horizontal line test. So if you draw a horizontal line, you see, if you draw the horizontal line, you'll be in trouble. Sorry, that's what, you know, you get lots of points, you know, it must be here. Okay. So as you can see, if you draw a horizontal line, those lines will intersect the graph at more than 1 point. And so this means in general, okay, so this means in general, in its own period, and the function, okay. So I just remind you that the horizontal line test, horizontal lines intersect the graph, the sine graph of y equal to the sine x at more than 1 point, because of that the period of the function. Okay, so So basically, therefore, y equal to the sine x is not invertible, has no inverse, of course, on its entire domain, if you like, entire domain. Okay, so entire domain, you may take the domain would be 0 and 2 pi. Even in that period, you see, in that period, you get a horizontal line that intersects the graph at more than 1 point. So what are you going to do? You are not going to leave it because you would like to define that. So you have to consider a portion of this graph that satisfies the horizontal line test. You see, look at this one to see why we get this one. Why we get 2 points. You see, when we start from here, we go up and down. So that's why we get this, we get 2 intersection points. So what we can do, we have various choices. We can consider the graph only in this portion. You see this portion? So start from negative pi half, going to the positive pi half. If you consider only this portion, so if you draw any horizontal line, that would only intersect the graph at 1 point. So you can pick this one between negative pi half and the pi half, stay here, then it's going to be invertible. You have other choices. You can go this one. You can pick between the pi half and the 3 pi half. That gives you 1. Or you can pick this one. Okay, so you can pick those numbers, different intervals to be able to find it. But the reason that we pick negative pi half and pi half is for calculus. And I'll tell you later. You see, the reason that we pick this one, there's going to be lots of calculations that we use with the inverse function, inverse sine function. Always, most of the time, we end up with taking the square root, like the alpha half that I did. When you want to take the square root, okay, there is going to be involved with the square root of the cosine. So the reason that we get the negative pi half and the pi half, negative pi half and pi half is going to be either the first quadrant or the fourth one. In the first and the fourth, the cosine is positive. That's the only way, the only reason that you pick this one, nothing else for future, for calculus. Okay, you can pick any other you like, but since you want to use it in future, you have to follow our guidelines, okay, our guideline if you like. So there are various choices, but we pick the best choice for future, for the application, okay? So we continue. So therefore, y equal to sine x has no inverse on its entire domain, but, you see, but if the domain is going to be, if x is going to be between negative pi half and the pi half only, okay, then your function y equal to the sine x has an inverse. Has an inverse on what domain? On the domain d equal to negative pi half and the pi half. That's the most crucial part of these ideas, really. And you must know this one if you want to take, this course into any other courses. You must know that the domain that you are going to pick to get the inverse function of the sine. So in this case, you see, look at this one. Just that portion of your graph that we talk about it. So this is going to be pi half. Okay, and this is going to be negative pi half. And the top will go up to the positive 1, negative 1. So this is the one that we are interested in. So that gives us the maximum here. Okay, and the kind of minimum here. So that portion of the graph, that portion, you see, this is it passing through the origin. Okay, getting this one. So this is where we are going to get the, so this is y equal to the sine x, but with the condition that x is between negative pi half and the pi half, and you know that y would be between negative 1/2 and the positive 1/2. You can draw as many horizontal tangent line as you like. You never get more than 1 point. You see the horizontal line? Horizontal line intersect this graph at 1 point only. So that was just a preview to tell you that how we're going to define the inverse of a sine function. We say, oh, if you give me a sine function with this property, then I can define the inverse trigonometric function. Okay, any question? So this is how we are going to get the first definition that we have. We have to do this one for all the cases that we have. We have to decide which portion would give you an inverse and which portion are going to use. As I told you, the reason is calculus. Some people, they think that it's just for fun that we pick this one. No, the reason is future. You see, this is future. This is going to be the unit circle. Okay, you know that if you want to have a negative numbers, this is going to be 0 instead of going from this side. So we do it the other way around. So this is going to be our, okay, this is going to be the pi half, and this is going to be a negative pi half. Here, come from here, this direction, negative pi half. Okay, so in this case, the situation that we're going to have is going to be, I'm sorry, the other way around. This is it. The direction is this one. Okay, counterclockwise if you like. So if you are going to be between negative pi half and pi half, you see this is cosine. This is going to be cosine. Cosine is always positive. And various problem are, anytime we use it, we end up taking the square root of the cosine. And we want to get only, we get positive negative. So since cosine is positive, the result of that is square root will be positive and we be safe. There are many, many problems, especially in calculus too, if you want to take those courses. Okay, so remember the domain for the sine inverse. Now we are ready to officially define it. What is going to be the sine inverse function? Okay, so we change the notation and we get this one. Any question? So that's the interpretation. The reason is important, but otherwise, if you want to memorize, this is it. They start from this part. They give the definition, but it's nice to know it. So what's going to be the definition of the inverse function? There you are. Okay, the inverse sine function. The inverse sine function. Sine function is going to be denoted, okay, denoted by, that is going to be the notation that we're going to use. Y equal to sine inverse of x. Okay, we switch the x and the y. Is going to be y equal to the sine inverse of x, and is defined by, the definition that we talk about it. Y is equal to the sine inverse of x if and only if you switch. Anything you want to do, you have to start with this definition. You switch, x is equal to the sine inverse of y. But the condition that we talk about it, this angle must be, okay, this is going to be where this y is going to be between, okay, this is it. It's going to be if and only if the, okay, the y is going to be where y in this format is going to be between -1 and +1. Okay, and this x, I'm sorry, I made it, no, that's correct. X equal to the sine pi. And y is going to be between -1 and 1, and your x is, sorry, that's a pi half angle. And the pi half, okay, the angle, and x is going to be between -1 and +1. Anytime you write it down, this is pi half. Okay? So anytime you write it down, you have to put the condition. Remember the condition? The angle must be between -pi half and the pi half. And then automatically x would be between -1 and 1. So therefore, for this function, okay, so y is equal to the sine inverse of x. The domain of this function, the domain means the x's are going to be between -1 and 1. The range of this function, the range of this function between pi half and
yes.
pi half. You see, that is going to be the information that we are going to have. Okay, and if you want to see the graph of this function, you see, this is the graph of the you see, we have the original one that we did have. Remember, the original one was what that. This is the pi. Okay, that was a -pi half, and that was the pi half, and we put the +1 on the top, and this is okay. This was a -1. Remember this graph? You get a maximum here and the minimum here. So that was the graph of the, okay, that was the graph of the, okay, the graph of the sine function, if you like. Okay, that's a graph of the sine function. This is sine function. Now, if you get the inverse, you just switch it. You see the inverse? You switch that x to y. So the inverse is going to be the inverse. The domain is between 1 and -1. So you have to put the 1 and -1 here. This is going to be a -1. This is going to be a +1. You go up as this is going to be the pi half on the top. Okay, and this is going to be a -pi half down the bottom. Okay, now the points that we did over there are going to be here now. You see, this is going to be 1 point, and this is going to be another point. So it's a kind of, you know, it's going to be like the other one. So this is going to be something like, okay, this format. The shape is going to be different, if you like. So this is going to be sine inverse graph. Okay, so we switch the x and the y for the domain and the, okay, domain and the range. So it's a function. So for each x, you get only one y out. Anything you want to do with this function, anything, you switch it first. Because you don't know anything about this one, but we know quite a lot about the other ones. So you switch it first and you stay here to get your final answer. Okay, so let's practice. Your job is just, you know, evaluate it for us. We give you some numbers to be able to do it, get to know it, because the various property of this function is going to be given to you, you know, if you continue taking courses, especially in calculus. But for the time being, just it's algebra, if you like, algebraic properties. So you may be given, asked this type of question. No calculator, of course. We want to find the exact value. Okay, so find the exact. Okay, find the exact value of each quantity, if you like, of each quantity. Just the exact value. Okay, and this is the way we are going to ask you a question. Okay, so the first one, for example, we may ask what is going to be the sine inverse of 1. So this basically means find an angle whose sine is 1. Because when you get the sine function, you find the sine of 45 degrees, for example. But when the sine inverse means find an angle whose sine is 1. But this is the way we do it. We know it, but you have to write it down for us, okay? Get used to it. So kind of solution. Some of them are easy. You can tell us right away, but I want you to see how we solve it. You see, anything you want to do, you are going to call this one, you see the sine inverse of 1. Okay, you are going to call it anything, you can call it y, you can call it theta, alpha, it doesn't matter. Okay, so you are looking for an angle. Say, oh, suppose this is equal to the theta. Then you switch, or x, alpha, whichever you feel comfortable. Okay, then as soon as you write it down, you switch it. Switch means you are going to have a sine of theta is equal to 1. But you write where the theta is. It's very important. You know that in the case of the sine inverse, we are going to be between negative pi half and the pi half. You must write this condition. Then go and find it. You want to find an angle whose sine is 1. You know that that angle is what? That angle is, okay, 90 degrees. Okay, so this will tell you that the angle is 90 degrees. Okay, so you go back and substitute. You say that the sine inverse of 1 is equal to the pi half. This is how we do it. Any question? So sine inverse of 1 means find an angle whose sine is 1. You know that that angle is 90 degrees. But you must make sure that you are in this interval. Okay, in the given interval. Call it theta, call it alpha, switch it. Sine theta equal to 1. Go to the unit circle, you find it. You want to find an angle whose sine is 1, but make sure that you are in this, okay, in this interval. That's the first one. Any question? The difficulty sometimes is when you have some negative numbers like this one. Okay, we give just a couple of them and then be done. This is it. We want to find what is the sine inverse. Sine inverse of negative half. So this means find an angle whose sine is negative half. If you want to do it quickly. But I suggest that just go with the formula. You call the sine inverse of negative half. You want an angle, call it theta. Switch. So this means the sine of theta must be negative half. But remember, you must be in this interval. You must be in this interval. You can go to the unit circle and find it. Or you see, this is the idea. If you go to the unit circle, you look for the positive 1/2 first. Positive 1/2, you know that this is sine of the 30 degrees. The sine of 30 degrees is 1/2, which is going to be what? It's going to be pi 6. You want it to be negative. You know that the sine is going to be negative here. Okay, the sine, you will get one number here. Or you may get it here. So if you are going to be here, it's 210. But remember, theta must be between negative pi half and the pi half. So you're not going to pick this number. Your number must be here. You see, this is a negative pi half, and this is going to be the pi half. So you have to pick this number. This number is going to be, you see, it's 330 degrees, but since you wanted to be negative, this is the 30 degrees, this is going to be negative 30 degrees. negative by 6. Okay, so your data is going to be equal to the negative by 6. Any question? It's very important to pick the correct one. You see, negative 1/2. If you go to the table, you will see it here. 7 by 6 is no good because you must be in this interval. On the other one is here. The other one is here, 11 by 6. 11 by 6, 330 degrees. But remember, you cannot pick 330 degrees. But the corresponding one is negative by 6. So the solution is going to be negative by 6. So the sine inverse of a negative half is going to be equal to the negative by 6. So make sure you get the, pick a correct one when you're dealing with these numbers. Any question? So just use your unit circle, but in this case, you are going to be between negative pi half and the pi half. So you may pick a negative number. You must pick a negative number. So you will see the negative 1/2 when you go around the circle. You will see the one here, third quadrant, the other one, the fourth, but you have to change the fourth one into the negative, okay, to get that. So the answer is going to be negative by 6. Any question? Sometimes that number is not going to be in the circle, unit circle, okay? So if they ask you for sine inverse of 1/3, okay? So you are going to use the terms that we talk about it. You see, the solution is going to be, so you let sine inverse of 1/3 to be equal to the data first. Then you switch it, that give you the sine of theta, okay? That give you the sine of theta is equal to the 1/3. Okay, then you have to use your calculator for this type of numbers, okay? If they ask for the value, you see, we don't usually, if we ask for that value and then you go to your calculator and you know that the notion of the sine inverse in your calculator is already given to you, okay? So this is going to be my calculator. Okay, so I want to find the sine inverse of the 1/3. So that's it. You go to the second, and this is going to be the sine inverse. Sine inverse of the 1/3. Okay, one that is going to be third. So you click. So my calculator was set on degrees. Give me
99.
give me 19 degrees. If you change it into the radian, in that case, you can write 90 degrees or in a radian. Okay, so this is going to be, okay, 19.5 degrees, but if you set it on radian, I think you get 0.34. Okay, so, we may give you some application problems, then you can use this type of ideas, but we mostly going with the exact value, and we are going to be interested on those type of problems. But you have some problems in your book that they ask you, okay, they ask you to get them, exact value. So we got to be careful to get those, those exact value as they wanted, if you like. Okay, any question? So these are the terms that we're going to have. There are a couple of more, to get these type of examples. Okay, the example is going to be, they want you to evaluate again. Okay, find the exact value. This is a property that we may check to see. Okay, they ask something like, okay, they want to know what's going to be the that's it, the sine inverse, the sine inverse of the sine of the, let's say, 5/8.
Oh.
This is going to be interesting. You see, some people, there is a property that, you know, that it's like, inverse is going to be, this is the function and this is the inverse of the function. If you if you apply both of them together, you should arrive at the 5/8 again. It's like, you know, what is the reciprocal of the reciprocal of 5? You see, reciprocal of the 5 would be 1/5.
Yeah.
But if you apply it again, you must get the 5. But you got to be careful because of that domain that we talk about for the sine inverse. So what we do is we can find the sine of 5/8, okay? Sorry, let's call it 5/6 to be able to find it. 5/6. So what we do is, first we are going to find, okay, the solution is going to be, we go to the table and we find what is the sine of the 5/6. You know that the 5/6 is going to be 150. Okay, it's going to be 150. And the sine of 150 is the same as the sine of the 30. So you are going to arrive at, okay, that's it, yes, 5 times. Yeah, you arrive at this, you arrive at the 1/2. Okay, you get the, this is it, it's going to be arrived at the 1/2. So then you are going to find what is going to be the sine inverse of the 1/2. Okay, in this case, you are going to get the same one. Okay, the sine of the 1/2, you know, you can call it theta, and it's the same thing. So that give you the sine of the theta equal to the 1/2. But remember, the theta must be what? Theta must be between pi half and the half. So in this case means this must be in the, okay, in the first quadrant on the, because this is, you want it to be positive. Okay, the sign is going to be positive into the first quadrant, and the, okay, so this is going to be, this is it, this is good, that was correct, yes, that's it. Yeah, you see the sign of the data is going to be 1/2, since data must be in the, between negative pi half and pi half. So this means in this case the data is equal to the pi6, okay, the 30 degrees. Okay, so for the first part that you find it, sine of the 5/6 is going to be 1/2. Then sine of the 1/2 is equal to the data, but data must be in the first quadrant. So this means the sine inverse of the sine of the 5/6 is equal to the pi6. You see? So you got to be careful. It's not like the, sometimes it's equal to if you are going to be in the first quadrant. But you must be careful. Always check it yourself. Okay? Check it and don't memorize anything. That's going to be the, you know, the case that we're going to have. Okay, so this is going to be the situation that we're going to have. Okay, the sine inverse of the sine of the 5/6. You have some examples in your book, and then they ask you to, you know, they ask you to check whether we get these type of numbers. Okay, any question? So this is one version of these problems. Now we have one more case for this type of problems that you got to be careful. So this is a type 1. The type 1 is a straightforward. We're going to ask you one of these sine inverse for us, just using the table to find it. Now, the other one, a little bit more technical. You should be able to do for us. This is example. We practice more on the sine inverse. Then when we get to the cosine or the tangent, that would be easier for us. Okay, let's see. This problem is very popular. You may be asked, find the exact value. You see, find the exact value of, look at this one, cosine of the sine inverse, okay, of the negative 1/3. You see, the problem that I did for you, it was a nice number. You see, 1/2. But this is negative 1/3. These problems are very popular. This is cosine. You may be given the tangent, the secant, okay, whatever. So how are we going to handle these type of problems? So you have to handle the inside first, you see. You start with that inverse part that you'll be able to do something about it. So what we're going to do, as usual, we are going to call this one data, because the only thing that you can work with it if you switch it. So that's a step one. You see one of these in your next test. Okay, so you are going to suppose that sine inverse of the negative 1/3, you call it data. As soon as you call it data, you switch it. That give you what?
Data.
Sine of data equal to the negative 1/3. But remember the condition. Negative pi half and the pi half. Okay. So this is going to be a situation we're going to have. But what we are looking for, we are looking for this one. What is this one now?
Cosine.
That's it. You say, oh, but cosine of the sine inverse of a negative 1/3. Now it is going to be, you see, this is data. It is going to be cosine
Cosine
of the,
data.
that's it. So it's like sine of the data is given to you. You want to find the cosine of the data. You see, as soon as you substitute, this is going to be something that we'll be able to find it right away. Okay, so we start working on this one. You know that you can use the right triangle version. Just check where you are. We say, oh, sine of the data is negative 1/3. Okay, and the data is going to be in the, where is the data now? You see, the data is, you see, this is going to be the one. This is it. You know that you must be in the first quadrant on the
In
fourth.
the fourth.
It's going to be the fourth because the sign is negative. So you are here. Okay, you are here. You can use, the right triangle version or the X and the Y. It doesn't matter, whichever you want. Okay, so the cosine of the data is going to be negative. So we have the sign. Okay, different version. So you can go with the right triangle if you like. So this is the sign. What is the sign? Sign is, this is going to be our data. The sign is the opposite, which is 1, going with the parenthesis, which is going to be 3, or you may call it -3, it doesn't matter. So we have to find this part. What is this part? This is going to be 9.
8.
It's going to be 8. It's the radical 8. Okay, so this part is missing. Okay, so we have a
2 radical 2.
-1, which is going to be 9 minus 1, which is going to be 8.
2
So
radical 2.
it's going to be 2 radical 2. Yes, it's a radical 8, which is 2 radical 2. So this is going to be 2 radical 2. Okay, any question? So now we can find the cosine. We know that the cosine is negative. It's going to be negative. Adjacent, it's a 2 radical 2 over 3.
The professor isn't the
Yes.
cosine, I thought it was positive, it's quadrant 4.
Oh, it's positive. Oh, sorry. Yes, why is that negative? Thank you. It's positive.
Yeah.
Thank you. So it would be 2 radical 2. Okay, 2 radical 2 over 3. So we go back and we claim that cosine of the sine inverse, okay, of the negative 1/3 is equal to 2 radical 2 over 3. This type of operation is very popular in this, and that's any of these trigonometric function that we talk about it, okay? They give you one of these. Okay, so this is cosine. It can come with a tangent, okay, secant. So we are going to be ready for it to get these, you know, these numbers. Okay, and there are more. We talk about it next time. I think that would be enough. Okay, so get yourself familiar with the sine inverse, because the other one is very similar. We just give you the domain that's going to be possible. The next one is cos. We are not done. This section is very dense. This is the sine. We get the cosine. Cosine, the domain would be 0 and pi. Then we get the tangent. The tangent is negative pi half and the pi half. Then we put them together, and you know, we go around and give you various examples of these three famous functions. And that's all you can do in this course, just working with these formulas. But it's going to be, you know, great number of the applications for future. Okay, so we are not done. We continue with this one when you, okay, when you coming back, if you like. Okay, I think your break is next week, yes, a spring break?
Yes.
For your college. Okay, so that's it. Have a nice one.
Thank you, teacher. Thank you.
I will grade that quiz I posted for you so you can have a look. Okay, and then we come back, we take care of this. Okay, this section, as I told you, it takes a while to be able to do it. Okay, so, oh, it's 29? Or, okay, I double check it. I double check because I know what university is going to be next week. But Palmer College, okay. So maybe, yes, we are going. I double check that one and let you know. Okay, somebody said it's not next week. Okay.
Yeah, I think we do meet next week. Yeah.
I think the teacher.
Okay, I'll check
April
it.
1st, April 1st to April 6th.
Oh, okay. So we have a class next week. That's fine. Okay, I'll check it, you know, and then double check it. But anyway, and we have a class, it's a good one. We can finish this inverse function to be ready for your next test.
Oh, yes.
Yes, we have a test. Okay, I've already graded your, you know, I finished grading your first test. If anybody's grade is missing, just let me know so I can fix it. I think I fixed everything that I had. Okay, there was one of them that I couldn't open it, so I'm going to try it. But if any of your grade is missing, send me an email so that I'll be able to, you know, to find it and give you your grades.
Yes.
Okay, and there are going to be assignment too. Remember, make sure your assignments are going to be submitted on time. Okay, so if your grade is missing, send me an email, then I will fix it for you. That's fine. Okay, that's it. Have a good one. Take care.
Same to you, teacher.
Right. See you next week.
See you next week. Yes, see you next
See
week.
you, teacher, next week. Thank you. We appreciate it. Thank
Okay,
you.
have a good one.
Thank you.
Bye-bye.